Hello everyone and welcome back to Clear Creek Solutions Hydrology Education videos. We're on part 2 of our Model in WWHM-SWMM series. So if you haven't seen part 1 yet and you want to see how we set up the beginnings of this model, you can go to our channel at Clear Creek Solutions, or you can click here to view part 1 of the video series. Now we're going to get into more of the hydrology aspect, which is the pond modeling. So we set up our project here with a pre-developed scenario, 5 acres of till forest flat soil. Now we have this mitigated scenario with all this impervious area. Now we're going to design a detention facility to meet the runoff requirements and meet the flow duration requirements. In Western Washington, which is where I'm setting up my model, there's a flow duration criteria that has to be reached for modeling the pond. So we're not simply modeling volume, we're actually modeling the pond to a specific release rate for a certain range of flows. So let's disconnect the point of compliance here on this basin. And let's add a detention trapezoidal pond facility to the model by left-clicking. And then left-click to add it to the model space. Right-click on the basin, and then drag your marker to the pond to connect the basin's runoff to the trapezoidal pond. This is indicating where it's going. You can click on the outlet there to change it, extend it, or move it in the screen, but it doesn't matter where it's oriented on the modeling form. This is our trapezoidal pond element. Now, there's a couple different ways you can model this. We're going to start off with manually modeling it, and then I'm going to show you the auto pond feature. First, we have to connect this trapezoidal pond to the point of compliance, just like we did with the basin, because that is the new point of analysis now. So now that we have the pond connected to the point of compliance, we can take a look at the pond form here on the right. You can see there's a number of dimensions: bottom elevation, length, width, depth, the side slopes, whether you want to enable infiltration, and then selecting the outlet structure and orifice size of the facility. We can also name this facility whatever we want. I'm going to name the facility Detention Pond. So it's named Detention Pond. Now I'm going to input a few parameters in here so we can actually model this facility. One of the best ways to do that is to click the Quick Pond button. That's this up here in the top right. This will fill in a bunch of values for the pond form. It won't actually model the pond, but now you can work with this. If you want to view what the facility should look like, you can view the facility dimension diagram to see what a trapezoidal pond looks like, and how to correlate these different facility dimensions with the diagram and what's actually happening in the real world. And this is what the outlet structure data will look like, with the riser, with the diameter, a notch, and where the orifice is oriented. So you can see we're starting off here with an orifice of 3 inches at a height of 0 feet. We can see if a riser height of 6 feet is a 24-inch diameter. It's a notched riser type with a rectangular type, or riser type of notch type of rectangular, and has a 2-foot notch height and a 2-foot notch width. So what I'm going to do is run this scenario now, and we're going to see how this facility performs with our flow duration analysis. If we go to our analysis tab, which we saw earlier in part 1, we can see how this facility is performing. So you can see that it's performing okay for a certain range of flows, but not others. You can see a lot of the low flow ranges are still getting through and exceeding the time for the pre-developed flow. What I'm going to do is reverse the orifice diameter, or reduce it to 1 inches. So now we have a 1-inch orifice at the bottom as opposed to 3 inches, restricting that flow. Let's run the scenario again. Let's go back to the analysis tab, click on point of compliance 1, and see if the facility is performing better now that I've made the orifice smaller. So it's performing quite a bit better now that I've reduced the orifice, but this may not be the most efficient facility design. It's a 200 by 200 foot facility, which is quite big. The one option I am going to pursue is the auto pond feature. In WWHM-SWMM, you can use the auto pond feature to automatically size your facility to the most optimal size. So it's 200 by 200 right now. The auto pond feature is going to reduce that and make it as small as possible while still meeting your jurisdiction's requirements. To use the auto pond, I'm going to go to the slide the automatic adjuster to the right for the most thorough analysis. I'm going to leave it selected as a 1 orifice and rectangular notch, although 3 orifice is a selection that you can choose. You can also set what you want the length to width ratio and pond side slopes to be. I'm going to leave them at the default. Now let's click Create Pond. And what this is going to do is run through a number of iterations, trying to create the most optimal facility as possible. And then when this is finally done, because it can take 5 to 10 minutes, we'll take a look at the facility it's created. So, and you'll also be able to see here on the graph the change of the pre-developed and mitigated flow across that flow frequency range. So once that's completed, we'll come back and take a look at our facility. Okay, so we can see the auto pond feature is done running. I'm going to click OK. Let's look at our new modeled facility. We can see here that it's 90 by 90 feet in length and width. It has an orifice of 1.198 inch diameter, a notch height of 2.56 feet, and the width of 0.0164 feet. The riser is still notched, and then the notch type is still rectangular. The riser diameter is now 18 inches. So notice the 90 by 90 facility is much smaller than the 200 by 200, but because the outlet structure was modeled in a more efficient way, we're now able to get a facility that is not going to take up as much space. Let's go to the Analysis tab and look at Point of Compliance 1. We'll be able to see that the pre-developed and mitigated will be able to meet that flow range, but in a much more efficient way, meeting our local requirements. The key that we look for is getting that blue line and then that red line just beneath it and matching it. You can see the facility passes. So that's how we model a detention facility in WMSWM. We're going to start to add some hydraulic elements in the next video, so look out for part 3. Thank you so much for watching. Anyways, I'll see you guys next time.